See here, so this is the another different problem, very different compared to other previous problems. Earlier whatever they have given a simple line diagram, the simple line b a beam, whatever it is there, it will be shown as a one beam section. Support will be there, load will be given, and you ask to determine the reaction at the supports. So this is what you have been doing in the previous problem, but in this problem it is very different. So you can see here a beam ABCD having the self weight means self weight of this beam has its self weight, means any material how it has its weight, same like that this beam has the load self weight. So self weight, it is 2 kilonewton, is subjected as shown in the figure. The support reaction at B and C you have to determine. So this is what they have asked. So if you see here, compared to previous problem, one simple few changes are there. So when the sulfate it is given, whatever the given sulfate it is given, so the load of the beam which is acting exactly at the center. Don't forget that if the sulfate of the any beam section is given, that means the total load of the complete beam will be acting exactly at the center as a concentrated load. So you have to do this like this. Okay, so what is this? 20 kilonewton per meter. Okay, so what is the load? It is 2 kilonewton per meter. So load is here I will do it better, I will do it here only. Okay, load is 2 kilonewton. Okay, so load it is acting 2 kilonewton. What is the distance it is acting? 2 kilonewton self weight. So 2 3 5 7 7 plus 3 10. So totally 10 meter it is acting. 2 kilonewton it is acting at a 10 meter. So totally load of 20 kilonewton. 20 kilonewton will be acting exactly at the center. So length is 10 meter. So at exactly 5 meter another one load will be acting. So that is being shown here. Okay, self weight is been shown as 2 kilonewton at the center. So 2 plus 3 5. So 5 meter load it will be acting. So here it is triangular load. So it is will be 1/3 and 2/3. So 2/3 from this end and 1/3 from this end. So 2/3 from this end. So low 2/3. Okay, into distance of 2 meter. So it is 4/3 and one you take from here only. Okay, it is 4/3 from this end and 1/3 from this end. Okay, so 2 into 2 it is 4. So 4/3 and 1/3 from this end. Okay, so 4/3 this side it is 1/3. You always you take from this side 2/3 of its length. The concentrated load, the concentration of this complete triangular load will be acting at 2/3. Okay, 2/3 from this side. Okay, so that's why it is here, it has been shown here 4/3, and the distance here it is 1/3 into 1/3 of its distance. So it is 2/3. Okay, that has been shown here as 2/3. Okay, so this one is over, this one is over. This is the inclined force and angle it is been inclined to 10 degree. That I have resolved this as here. You can see here 10 degree variation. So here theta angle it is there. So I have written here. Okay, so theta is here. So this will be sine. So this will be the cos. So 10 cos 10. So load, the whatever the force which is 10 kilonewton. Okay, force is 10 kilonewton. So that's why it is 10 cos, degree also 10. So it is 10 cos 10 and 10 sine 10. Okay, so this all everything is over, but there is another one typical thing is there here. This is if the two forces which is equal forces which is acting opposite to each other, means that's a couple. Okay, so what you have to do is you have to find out. So that couple will be acting as a moment. Okay, so this 5 into, if you take from here to here, the distance is how much? 1.2. 0.8 plus 0.4 it is 1.2. 5 into 1.2, 5 into 1.2, that is 6 kilonewton. Whatever the 6 kilonewton meter one, this is in distance, it is in meter. So always the moment will be in kilonewton meter. Okay, so 5 into 1.2, the moment 5 into 1.2 is 6 kilonewton, so that's why a moment of 6 kilonewton will be acting. So how it is rotating? So it is rotating like this, so it is rotating like this, so it is rotating in anti-clockwise direction. So I have shown here as anti-clockwise direction as 6 kilonewton meter. So this is how the whatever the beam section, whatever it is there, I have been converted that into a free body diagram. So after converting that into free body diagram, so later what you have to do is you have to find out the reaction at B and reaction at C. You have to determine reaction at B and C. You want to determine. So here there is a two forces, because of hinge there is a two forces, and for a roller there is only one forces, that's all. Okay, so better what you do is take a moment at B only to nullify the two unknowns. If you take a moment at C, you will nullify only one forces. So if you take moment at here, so two forces will also be get removed. Okay, so that's why moment at B is equal to 0, anti-clockwise direction as positive. So take from here, you take it, so this is 6 kilonewton, so it is moving towards the anti-clockwise direction, so it is plus. Okay, this is over. Next you come here. Okay, 20 into 3, it is clockwise direction, so it is minus. So next here 5, so 3 plus 4 by 3. Okay, so only you will come to the this point. Okay, this distance is 4 by 3. Okay, 3 plus 4 by 3, so 3 plus 4 by 3, this is the distance. Force is 5 kilonewton, force into distance, moment is force into distance, that is 5 into 3 plus 4 by 3, because we are finding the moment at here. So 3 plus 4 by 3, this is over. Next, if you take RC into this total distance, so you leave it this one, so 2 meter total you take it, so 3 plus 2, that is 5, RC into 5. But when you come here, you have to be very careful. So if you come here, so this force will be acting, this horizontal force whatever it is there, that will be acting here. Okay, so that means if you take a line diagram, if you take it here, it will comes here only, so there will be no forces will be acting. So but that's why you better you take only the one force, that is a vertical force, that is 10 cos 10, so it will be acting here. Okay, 10 cos 10 into distance, 3 plus 2 5, 5 plus 3, so that is totally 8, so that's why 8 into 10 cos 10. Okay, so finally if you calculate this, only unknown thing is RC, you will get RC value. Okay, so after finding this RC value, you got it. Another vertical forces you have to determine, that is BY. Okay, so BY, take the vertical forces upward as positive, upward direction you take it as positive, so BY BY you take it as positive, so here I have taken BY as positive. Okay, you can see here BY, and another is this 20 kilonewton and 5 kilonewton is moving towards the downward direction, so that's why it is minus 20 minus 5. Next RC, it is moving upward, so that's why it's plus. Okay, next another forces is there, another force which is moving downwards is 10 cos 10, so that is also on a downward direction, that is minus 10 cos 10. Okay, so in this unknown forces, it is only the unknown forces is the BY. Okay, RC value you have determined earlier, you substitute the value of RC value and put the value, insert the value of the RC value and find out the value of BY. Okay, in this equation, so you can find out very easily here. RC value you have determined that one as 30.89 earlier only, so find out the BY value. After finding the BY value, you can see here there is a hinge here, there is a, due to two forces you will get a one reaction will be getting from these two forces. Okay, that reaction is equal to, so the resultant force will be the RB, resultant force RB is equal to square root of the BX square plus BY square. So BX already you have determined, BX value you have determined, BA value you have determined, substitute the BX value and BY value and find out the RB value, that is 4.325. Okay, after finding this you have to find out the angle of whatever the resultant force will be there, that angle you have to find out with respect to horizontal. horizontal, with respect to horizontal, you have to find out the angle. So that to find out that angle, so what is that? That tan theta is equal to uh, tan theta is equal to by bx. By here, bx is here. So by and bx value are already determined. By is 3.96 and bx value is 1.74. So substitute the two values here as I'm showing here. Theta is equal to by bx. So by is 3.96 and bx as 1.74. So finally find out the theta value as 6.28. So this completes the finding the reaction in the given beam section. Okay, next we will go on to the moment of inertia and centroid problem. We'll go to the new chapter and we will continue.